In example 5, we want to count how many 7-digit phone numbers are possible. So 7 digits. So 1, 2, 3, dash, 1, 2, 3, 4. Okay, that's a dash. Don't think of it as a minus sign, but a dash. But we have 7 digits here. Kind of like we had 15 slots for the test, we have 7 slots here for a phone number. If the digits can repeat. Okay, so 1, 2, 3, 4, 5, 6, 7. Well, think about it for a phone number. That first number, that first leading number, I mean, it really doesn't start, I wouldn't include 0, but just for sake, just because we can, you have the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 options for that first number. And if it says that we can repeat, so you can have a number that says like 555, 4932 or something, then really I have 10 options for each potential slot. Or we can say, because we always multiply these together, remember the multiplication principle, so we have 10 to the 7th total options for a 7-digit phone number. Now this next part says, what if I go through here and the digits can't repeat? So starting out, that first slot, I still have all numbers I can choose from, 0 to 9. So I have 10 options. But at this point, I've used up one of them. Like let's say that number was a 1. So now for the second slot, I can't choose 1. I can go 0, then 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 options. Okay. So when I go to the third one, I've already used up 2 numbers. So now I only have 8 options left. And you're kind of getting the idea. It's just going to kind of trail down all the way down to 4. So putting this in our calculator, just if we want to see, we'll get a total of, looks like 604,800 phone numbers that will have potentially all completely different numbers in there. And if we did 10 to the 7th, that's 10 million. So it goes from 10 million down to 600,000 whenever we can't repeat. So we almost have only half as much phone numbers we can use from. And then part C says, what about if the phone number can't start with a 0? Okay, so 1, 2, 3, 5, 6, 7. Doesn't say anything about we can't repeat, so we're going to assume we can repeat. Okay, so let's write that down. Assume repeat is good, or is okay. So let's go to that first slot. Always start with the first. If I can't start with a 0, that means I can only go 1 through 9, so I have 9 options. Now let's go to the second one. The second one didn't say anything about I can't repeat, so we're going to assume it's good. So in the second slot, I can now start with 0. I can include 0 and go all the way up to 9. So 0 through 9 is actually 10 potential numbers. And then 10 again, and 10, and 10, and 10, and 10. Okay? So all that. Now, let's just play what ifs. What if we can't repeat? How would this change if we can't repeat? So let me get my 7 slots. Okay, this first slot just says I can't have a 0 in there. So 1 through 9 are technically 9 possible options. Now, if we go to this next slot, I can now include 0, but 1, 2, 3, 4, 5, 6, 7, 8, or 9 was used in that first slot. So I still though have 9 options because I can't, let's say the first slot was a 4. Then I can't include 4 in my second number, but now all of a sudden I can include 0 though. So I still have 9 options. And I've used up a total of 2 of the numbers, so now I'm back to 8, 7, 6, and 5. And then 4. So you kind of definitely have to stay on top of your toes as far as what they're, read everything closely with a fine-tooth comb, whenever you're saying, okay, can we repeat, can we not repeat? We got to think about all those options, because this can definitely get tricky, and this is a different kind of math, which is kind of, really, out of all of this, it's basic math. It's just multiplication. You just have to sit there and go, okay, my logic thinking skills. Let me get these things out again and try this out. All right, example 6. We want to find how many whole numbers. So whole numbers, obviously not decimals like 0.5s and all that stuff, but we want to find how many whole numbers that are less than 600 that can have 3 different digits. Specifically, those 3 digits can come from 1, 3, 5, 7, and 9. Okay, so let's think about this. My grand outcome is trying to get a 3-digit number. I know for a fact that I have to be less than 600, so it has to be less than or equal to let's say 600. Well, let's go to this first slot right here. I can only pick numbers 1, 3, 5, 7, and 9. Well, if I have to be forming a 3-digit number that's smaller than 600, technically all I can use is 1, 3, and 5, right? Because if I start with a 7 over here, like if I wanted to write the number 721, that's not going to be less, or 731, it's not going to be less than 600. So for this first slot, in order to give me a number that's less than 600, I only have 3 options. I can only choose a 1, a 3, or a 5 to start that out. Okay, does that kind of make sense a little bit? Now, real quick, we have to have 3 different digits. So when I go to the second number and the third number in the slot, okay, we got to think here for a second. How many numbers do I have left to choose from? Well, I can only use 1, 3, and 5 for the first digit. So let's just say I took away one of them. Okay. How many options do I have for the second digit? Well, I could use the 1, the 5, the 7, and the 9. So 1, 2, 3, 4. I have 4 options then technically for the second digit. And then let's say I took one of those away, then I only have now 3 options for the third digit. So the grand total number of options then of any kind of 3-digit numbers that have 3 different digits and it's still going to give me something less than 600 is 3 times 4 times 3, or 12 times 3 is 36. So there's 36 different 3-digit numbers that are going to be less than 600. And if you kind of want to just to get practice again, what if we said that it had to be, let's say, less than, let's say 800. So if we give ourselves just 3 options, those 3 digits, we think less than 800, okay? Well, if I'm going to have a number less than 800, and I can start with a 1, a 3, a 5, or a 7. So I can pick any one of those first 4 numbers. I have 4 options for that first digit. And if I can't repeat, so I'm going to say, let's say I take one of them away. Then for that second, I can do a 1, 5, 7, or 9. So 4 options there. Take another one away, and then I have 3 options total left over. So this time I have 48 total options. So kind of hopefully it's getting a little hang of it, but let's go on to the next part. That first part was all just the foundations on the multiplication principle, which means to get the grand total of number of options, we just multiply the different sub-options together. Okay, now we're going to introduce some new terms to you guys. Some of you might have heard of these, a permutation or a combination. Okay, a permutation is, I'm going to read this slowly. So what a permutation is, and when you have n distinguishable objects, so distinguishable means I can tell them apart. You don't just have like 5 white envelopes. There's a way to tell them apart. Like one's going to be red, one's going to be blue, purple, that kind of thing. So if you have a total of n distinguishable, n being like 10 objects, or 4, if you have 4 different cars or something like that, you can tell them apart. Then if you want to know the total number of ways that you can arrange those in an order is by a permutation. So what we're talking about here is, let's say I have 5 books and they're all different books, and I want to know how many ways can I stack them. This is all about a permutation. Or let's say I have 10 people. How many ways can I rearrange those 10 people in a line? We're talking about a permutation, okay? And specifically, if you're going to arrange all of them, so out of all those 10 people, I want to line all 10 of them up, not just 8 of the 10 or not 3 of the 10. I want to take all 10 people and rearrange them. Then what we're talking about is, this is a new term right here. It's called, that n with that exclamation point is called n factorial. And factorial just means you start with that number, whatever n was, and you start with that number and multiply always all the way down to 1 in consecutive order. So 10 factorial will be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And look here, again, all multiplied together because it just basically builds off the multiplication principle. So the total number of ways that I can arrange 5 books on a bookshelf, if I'm going to use all 5 of them, is 5 times 4 times 3 times 2 times 1. Okay, so let's get started here in example 7. We want to know how many different permutations or how many different orderings, permutations and rearrangements, orderings are kind of all synonyms with each other, of the letters A, B, and C exist, and what are they? Okay, well when I have letters A, B, and C, there are technically 3 letters, right? So my n in this case is 3, and I'm going to use all of them, and I want to rearrange all 3, so it's 3 factorial, or 3 times 2 times 1. So there should be 6 different ways I can rearrange the letters A, B, and C. So let's write them out. There's A, B, C, there's A, C, B, there's B, A, C, B, C, A, C, A, B, and C, B, A. There's all 6, just like that. So obviously, with something small, we can list them all out, but when you get to something like 10 factorial, definitely not going to want to list them out for sure. All right, let's go to example number 8.